Alright, so in this video, we're going to be doing some parametric derivative problems. We have our first problem up on the board here, find dy dx, and we're given our parametric equations, x equals t over 1 plus t, and y equals the square root of 1 plus t. Alright, so we need to find dx dt and dy dt, right? Because remember, dy dx is equal to dy over dt all over dx over dt. Okay, so first let's find dx dt. Alright, dx dt is going to be equal to, well, we got to do some quotient rule sadly here. Alright, well, u prime, that's just going to be 1, alright, over v, that's just going to be 1 plus t, minus, it's going to be the derivative here, which is, again, just 1, and that's going to be times t, over v prime, which is 1 plus t squared. Alright, so there is dx dt. Now we got to also find dy dt. Well, that's just going to be 1 over 2 rad 1 plus t. Okay, great. So we have these, we can literally just put them into this equation and we have our derivative. So dy dx is going to be equal to, it's going to be 1 over 2 rad 1 plus t over 1 plus t minus t. That means these t's are going to cancel off here. Okay, so we're just going to have these go away. It's going to be 1 over 1 plus t quantity squared. Alright, if we flip this up to the top, we're going to get 1 plus t squared over 2 rad 1 plus t. Okay, and really, this is just a 1 plus t to the 1/2. So we can use some exponent properties here to just rewrite this as 1 plus t to the 3/2 all over 2. Alright, so that is going to be dy dx, right? So we're just taking our derivative with respect to time of x and our derivative with respect to time of y. Alright, and then put those together in our equation and we get our dy dx, right? We get our derivative. Alright, so we have our next problem up on the board here. X equals t cubed plus 1 and y equals t to the 4th plus t. Alright, so those are our parametric equations, and we need to find the tangent line at t equals -1. So to do that, first we need to find dy dx. Okay, so we need to do that. We can do that by finding our derivative of each of these, right? dx dt and dy dt, which is going to be 3t squared for dx dt, and for dy dt, just going to be 4t cubed plus 1. Alright, putting that into our equation, right, it's going to be this over this, so dy dx is going to equal 4t cubed plus 1 over 3t squared. And what will this slope be when t equals -1? Well, we just plug -1 in for t. We're going to get a -4 here plus 1, that's -3, over a 3 times -1 squared, which is just going to be 3. So that's just going to equal -1. Alright, now we can just try to find our tangent line, right? With using y equals mx plus b. Well, what's our y? Our y is going to be -1 to the 4th, which is just 1, minus 1, which is 0. So 0 equals m times x, right? Our m is -1. And what's our x? Well, if we plug in -1 for t here, we get -1, and then we have to add 1, so that's going to be 0. So -1 times 0 plus b. As you can see here, b equals 0. So the equation for our tangent line is just y equals -x. Alright, so that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for parametric derivatives, and the next video in the series. See you soon.